Okay, here we are, Trig day number 5. We're going to do a little bit more with solving equations and sum and difference identity work as well. So let's get started. Okay, so I'm going to just give a brief overview of what's going on here, and then we're going to try one of these problems on a homework problem a little later into the notes here. But say I have sine of x minus root 3 cosine of x equals k, some value k times cosine of x plus b. Right, well, I see, x involved here, but I don't see b. So this is a really interesting topic here. Basically what I do is I set these two equal and then I expand this cosine of x plus b, and it gets into this form, right? So I've got k, some value k, distributed to cosine x cosine b, right, minus sine x sine b. So this term right here, sine x sine b, I see something similar to that here, right? And the cosine x cosine b, I see something that resembles that here. So like I kind of want to say like cosine of b equals negative root 3. We can see if we can do that here. Well, what I would have, right, is I have the cosine x accounted for. So basically what we've said then is that this term should equal this. So we set them equal. Of course, the cosine x's would cancel, and I get negative root 3 equal to k times cosine b. Squaring both sides, you can see then that I square k, I square cosine, I square the negative root 3, and I do the same thing on the other side. Right? I take k times this, and that'll equal sine x. And then when we get to this point here, we can add the two together and solve for k. Alright, so if k equals 2, then we can show that cosine of b would equal negative root 3 over 2, and sine of b would equal negative 1/2, and then we could find that the angle b is equal to 7 pi over 6. So let's get to an example. It might not have made sense the first time through here, but we'll get to one here in a minute. A couple tricks. This is kind of a side note, but a couple tricks for solving trig equations is solve for a single function first, know your unit circle, and then just understand that if I have example here, sine of 3x equals negative root 2 over 2, typically there's two solutions for that within 0 to 2 pi. But whatever this number is, in this case 3, typically we get two solutions, but since we have a 3 on the inside, that graph will be oscillating 3 times as fast, so we would end up getting 6 solutions. We'll get to some problems later where we can look at that as well. Okay, so let's use this idea, right, that 2 cosine of theta minus pi over 3, we want to show that it equals that. Alright, so what is 2 cosine of theta minus pi over 3? Well, that would be 2 times cosine of theta cosine of pi over 3. Alright, this is just, I'm just expanding this, plus sine of theta times sine of pi over 3. Alright, so let's leave that 2 on the outside and let's just evaluate. What is cosine of pi over 3? Well, I believe that's 1/2. So I get 1/2 cosine of theta. And over here, the sine of pi over 3 is root 3 over 2 sine theta. And then I just go ahead and I distribute that 2. That 2 will cancel with that, and it'll also cancel with that. And so I get cosine of theta plus root 3 sine of theta. And I'm proving it. Alright, let's move. Okay, here's a really interesting one. These problems are kind of all over the place, but we'll just roll with it, okay? Let's see here. Tangent. We want to show that a plus b equals pi over 4. Hint, what is the tangent of pi over 4? It's 1. Okay, so notice the markings here. Each of these lengths, these segments, are equal. So let's just write a couple things out. The tangent of pi over 4 will equal 1. The tangent, in this case, of b will equal 1/2, right? I have one part here, and I have two parts here. All right, the tangent of a will be 1/3. So let's write out the tangent, the tangent of a plus b. All right, let's just write this out. Well, that would be the tangent of a plus the tangent of b over 1 minus the tangent of a times the tangent of b. Let's fill a few of these things out. Okay, the tangent of b is 1/2. Okay, so let's replace that with 1/2. The tangent of a is 1/3. Okay, 1/3. So the tangent of a is 1/3. The tangent of b is 1/2. Let's see here. What do we get? So the tangent of a plus b equals 1/3 plus 1/2. Well, 1/3 is 2/6. 1/2 is 3/6. So I get 5/6 in the numerator. In the denominator, I get 1 minus, look at that, 1 minus 1/6. So the tangent of a plus b equals 5/6 over 5/6, which we know is equal to 1. Right? Tangent of what gives us 1? Well, a plus b must then be the inverse tangent of 1. Inverse tangent of 1 is 45, or pi over 4. Proven. Let's go. Next page. Whoops. Next page. All right. Okay, here's one of those problems that I was just talking about. So let's do this. Let's expand. Okay, let's write root 3 sine of x plus, I'm going to write this as 1 times cosine of x is equal to k times, let's write it out, sine of x sine, cosine of b plus sine of b cosine of x. Okay, let's identify a couple of things here. Alright, so I see root 3 sine x here. So this would be k sine x cosine of b. So if I set those equal, it'd be root 3 sine x is equal to k sine x cosine b. Alright, so the sine x's would cancel, and root 3 would equal k times cosine of b. Alright, let's square both sides. So we get 3 is equal to k squared cosine squared b. Let's hold on to that for a minute. All right, let's go to the other portion of it. All right, I've got 1 cosine x equals k sine x or sine b, sorry, sine b cosine x. So again, cosine x's will cancel. So I get 1 equals k sine of b. I square both sides. And I get 1 equals k squared sine squared b. Alright, now our next step, I'm just going to scratch this problem. Get out of here. Get out of here, problem. I'm going to add those two together. So I'm going to add the 3 and the 1. So I get 4. And then I'm going to factor out the k squared. And that gives me sine squared b plus cosine squared b. Which means that 4 equals k squared times 1, so k has to equal 2. Okay, so now I found k equals 2. All that I've taken is this before I squared it and this before I squared it, and I'm going to plug a 2 in there. So that tells me that the cosine of b equals root 3 over 2. And the sine of b equals 1/2. Okay, they're both positive. Therefore, it's got to be in quadrant 1. Sine is 1/2. Cosine is root 3 over 2. That angle must be, b must equal pi over 6. And I think that's what we needed to find. Find k and find b. Yep, we found k to equal 2. And b, I guess that was supposed to be a lowercase b, to be pi over 6. All right, let's try one of these. These are both exam problems, paper 1 problems from 2006. Let's look at the second one. Given that tan 2 theta equals 3/4, find all possible values of tangent. Okay, so tan 2 theta, let's just expand that. That's going to be 2 tan theta over 1 minus tan squared theta. Okay, and I know that that equals 3/4. Okay, it says all possible values, so it doesn't tell us like in any sort of restriction. So if I cross multiply, I'd get 8 tan theta equals 3 minus 3 tan squared theta. I think that's right. Yep, that's good. Ooh, yeah, I see something. I think maybe you will too. Let's do a little factoring. So let's bring it all to one side. Let's see if we can factor this. Alright, so how about that? I like that. If I foiled that, I get 3 tan squared plus 9 tan theta minus 1 tan theta minus 3. Okay, so if I want this to equal 0, then I want tangent to equal 1/3. If I wanted this to equal 0, then I'd want the tangent of theta to equal -3. Okay, therefore, I would want theta here to equal the inverse tangent of 1/3. Okay, I don't know what that is, but that angle would be our answer there. And I'd want theta to equal the inverse tangent of -3. Okay, now, tangent isn't like sine and cosine, right? So if I found sine and cosine have a period of pi units, or excuse me, of 2 pi units, but tangent has a period of pi units. So the tangent would be 1/3 twice within the unit circle. So what I would want here is theta to equal inverse tan of 1/3 plus pi k units. So I could make k whatever I want it to be. Right? And likewise over here, I would do the same thing. Pi k units. And that would give all possible solutions, regardless of quadrant, location, anything like that. All right, that would be day 5. Peace out. Have a good one. See you next time.